All right, boys and girls, this is Square Roots Part 3. 1, 2, 3, right? And this is homework 1, this is homework 2. We're going to go over these real quick, nice and easy, see how we do. All right, so now look. First thing you want to do with any of these kinds of things is you want to simplify any square roots that could be simplified. So the square root of 25 is 5, right? Minus 5 root 5 plus 5. The order in which you add and subtract doesn't really matter the order in which you add doesn't matter. And you can rearrange subtraction as long as you keep the signs appropriate. So this right here is 5 minus that number plus 5. That's equal to 10 minus 5 root 5. Done and finished. This is an irrational number. This is rational. You can't combine them, right? So we are done. Now, 48. Square root of 48. Well, the square root of 48 is the same as the square root of 16 times the square root of 3. So that's 4 root 3. 4 root 3 plus 3 root 3. Well, that's 4 of something plus 3 of the same thing. That makes 7 of those things. Do you see? Because 4 root 3 is 4 of them, and this is 3 of them. So, well, if we're gonna, I'll show you right here. There's 1, there's 2, there's 3, there's 4. That's 4 root 3. And then you got 3 more, right? There's 1, there's 2, there's 3. That's 1, 2, 3, 4, 5, 6, 7. See? There we go. All right, now here we got quite a few of these fancy-dancy radical expressions to simplify. So let's see here. We got to keep this right here. 25 times 3 is 75, right? And the square root of 25 is 5. So let's see, 24, well, that's 4 times 6. The square root of 4 is 2. 2 times 8 is 16. And this one right here is once again 5 root 3. This time it's plus, right? So, for example, 24, let's take a look at this one right here. The square root of 24, well, that's the same as, do you see? 4 times 6 is 24. That's 2. That's 8 times 2 times the square root of 6. And that's where you get 16 root 6. So, this right here and this right here, those make 0, so you're just left with 16 root 6. Done and finished. All right, now, this causes so much trouble. Look, when you're factoring these square roots, you want to factor to find the largest perfect square. The square root of 200, well, isn't that the same as 100 times 2? So that's 10 root 2. This is 2 root 2 times 8 is 16 root 2. And this is 16 times 2, which is, the square root of 16 is 4. 4 root 2, 4 times 2, 8. All right, so now we have square root of 2, square root of 2, square root of 2. You see, these two make 8 plus 10 is 18 root 2. It's kind of like this. The number in the front, this thing right here that's multiplying, it says how many of these there are. Right, so if you have 10 and then you add 16, that's 26 minus 8 is 18, you see? All right. It's just like, yeah, you don't add those. Those are what's already being added. That's describing how many of them there are. Okay, 49 times 2 is 98, right? And the square root of 49 is 7. So that's going to be negative 14 root 2 plus 16 root 2. These problems are written to be simplified. So you see how this one's got a square root of 2? That's probably going to be the same. So that's equal to 2 root 2, D-O-N-E, finished. All right, now we got a silly fraction right here. Deal with fractions, of course, is the denominator needs to be rational. This is 2, it's rational. That's 5, it's rational. So we just got to get a common denominator. We're going to multiply this one by 2 over 2, this one by 5 over 5. We're going to get 5 root 3 plus 4 root 3 over 10. Now that can be simplified. That's going to be 9 root 3 over 10. Done. Finished. Nailed it. All right. All right, next one. Okay. We got to simplify this. The square root of 6 divided by the square root of 3, well, that's the same thing as this right here. And that's the square root of 2. Do you see? So this is going to be 3 root 2 over 2. And it's done. This is 2. This is the square root of 2. They cannot be simplified. They have nothing in common. All right, now the next one. This is 4 times 2 is 8, of course, and that's equal to 2 root 2. You multiply that by 5, you get 10 root 2 minus 10 root 2. Not very good at math, but I think if you take a number and you subtract it from itself, you're left with 0. All right, 96. Oh, man. 96. Now, I'm not real sure about 96. Like I just did a minute ago, I did 48 because I'm familiar with that, right? Oh, it's 48 times 2, 96? Oh, my goodness. So, what we've got, let's see, 48 times 2, oh, 48 times 2, look at that, 48 times 2 is 96. Man, and we know that 48, so check this out. 48 times 2 is 96, and we know that 48 is 16 times 3 times 2. So, I'm thinking that 16 times 3 times 2, 96. So that's going to be 4 root 6. The square root of 96 is going to be 4 root 6. So 4 root 6, and then this is, of course, 2 root 6. We just did it. 2 times 3 is 6. That's 10 root 6. D-O-N-E, finished. When you're adding, the square roots don't change. Yeah, so like, you know, yeah, so anyway, this one 48, so that's 4 root 3 again. This is 3 root 3. 9 times 3 is 27. That makes 6. There we go. Now, cubed. Oh, man, that means multiplied by itself 3 times. So that'd be 3 times 3 times 3 times the square root of 2 times the square root of, maybe we'll do it this way. Yeah, well, the square root of 2 times 2 times 2. Right? So that's going to be the square root of 8. That's 27. Square root of 8. Now the thing with the square root of 8, that's 2 root 2, so that's going to be 54 times the square root of 2. Oh man, now there is a way we can use our calculator to kind of see if that's right, just to check, right? On a test, you're not going to, if on a test with this kind of math, you're not going to be allowed to use a calculator, but check this out. Let's go ahead and do this right here. Let's do 54, times the square root of 2. All right, so we get 76.37 approximately, right? Here's what I'm going to do. I'm going to plug that in right here. So we've got 3 times the square root of 2, and then cubed. Isn't that something? I think we're right. So that's a way you can use a calculator to kind of check your work. Let's see if you did it right. Now, this one's a little different. Squared. The thing I would do first, like even in the order of operations, you do parentheses before you do exponents. This might be something that could be simplified. 12 is 4 times 3. The square root of 4 is 2. So that's going to be 14 root 3 minus 4 root 3. Well, 14 minus 4 is 10 root 3. So when we square that, 10 squared is 100. The square root of 3 squared is 3. That's 300. D-O-N-E, finished. Okay. All right, so now some thinking problems, some conceptual questions right here. All right, so the first one says if m squared is equal to 7x, what is the square root of 7x? Well, this is asking, hey, what squared is 7x? That's what this asks right here. The square root of 4 says, hey, what squared is equal to 4? Well, that's 2. Because 2 squared equals 4, right? So this is saying what squared is 7x? Well, we know m squared is 7x, so it's just going to be m. Do you see? That's it right there. This is asking what squared is 7x? Well, we know that m times itself is 7x, so m. All right. Now, let's go ahead and take a look at that one again real quick, right? So look, we know this is true. We know that 3 squared is equal to 9. That's why that's true. Do you see? All right. Now let's move on to the next one. What is the largest prime number less than 100? Well, we got a couple choices. We got 91, 93. These are all the odds, right? 97 and 99. Let's do a little elimination right here. If it ends in a 5, it's divisible by 5, which means it has at least 3 factors, right? At least 3, but probably 4 or more. It's divisible by 5, so it's not prime. You can add the numbers together. Like 9 plus 3 is 12. 3 goes into that. So 3 goes into 93. 9 plus 9 is 18. No dice, right? This one I think is 13 times 7. So there we go. 97. I'm going to say 97. Whoa. Now, I'm not really sure. I'm going to use, look, this is homework. It's practice. So it's okay to check your answer and check your understanding. So let's see. Is 97 a prime number? Well, let's see what our good old friend, look at my busted old phone right here. It is. Glory, glory. And we know 99 is not, so we are done. Okay, the number n is a natural number such that the square root of n equals n. Well, n has to be 1 because the square root of 1 equals 1, right? It can't be 0 because 0 is not natural, so it has to be 1. All right, the number k is an irrational number such that k squared equals 27. So the exact value of k, well, we could actually even take this right here, we could solve it, you see? So k is equal to the square root of 27. That is close. We could simplify that. 3 root 3. That is the exact value. When you plug in to your calculator, oh, hold on here, let's see. The square root of 27. You see that right there? That is not exact. That is an approximation. Exact. This is a big, big deal. Exact numbers. Square root of a prime. That irrational number. That's the most exact way we can do it. We can write it. This is not exact. Okay? Anyway, let me know how that was. If you have any questions, issues, gripes, complaints, I hope you wonderful people have a great day. I hope this was helpful and useful, and I hope you learned something. So, anyway, there we go.